Hello students, you are welcome to study session 6, and today we'll be discussing hydrodynamics and hydrostatic. At the end of our discussion today, I expect that you'll be able to explain what hydrodynamics is and what hydrostatic is. You should be able to explain pressure and Pascal principle. You should be able to state Archimedes principle, and you should be able to explain what Bernoulli equation means. Various components of Bernoulli equation. You should be able to explain it. Now let's move to the main business of the day: hydrodynamic and hydrostatic. Hydrodynamic and hydrostatic are two branches of fluid mechanics that study the behavior of fluids at rest and in motion. When you hear hydro, what comes to mind is water, and the next thing that you should watch out from the words are the word dynamics and static. Now, when you hear dynamics, it means what is a motion, and when you hear static, static means what is stable, that is not in motion in a place. So hydrostatic focus on the equilibrium of fluid at rest and the pressure it exerts on a body that is inside that fluid. So that is what hydrostatic focus on. And on the other hand, hydrodynamics deal with the study of fluid that is in motion. So hydrostatic is fundamental to hydraulics, which involve engineering equipment for storing, for transporting fluids, yes, fluids majorly. It provides physical explanation for everyday phenomena like the use of hydraulic jack to lift your vehicles, how fluid moves from one place to the other, uh, what cause water to have a leveled surface when it fills a container. These and many more are things that hydrostatic and hydrodynamics deals with. And there is no way we are going to talk about hydrodynamic and hydrostatic that will not talk about pressure, because pressure is a very important thing to discuss when we are talking about hydrodynamic and hydrostatic. When you are discussing about fluid, pressure is a very important component to talk about. So when we talk about pressure, what are we saying? What we are saying is that you consider that you have water in a bucket, and there is a force F that is applied on the surface of the water. What I mean is, let's say this is a container and there is water that filled that container like this. By default, there is this pressure that is being applied on top, and this is the surface area of that. There is a force that is applied at the surface of the water, and this is the area of the container, so to say. So what pressure is about is that is the force, the ratio of this force to the area which it is applied. So that is what pressure is about. And you should also note that the force that is being applied is always the act perpendicular to the surface area. So that is what pressure is about. And the unit of pressure is Newton per meter square. Like we all know from our previous discussion, that unit of force is Newton, unit of area is a meter square. So the unit of pressure therefore is Newton per meter square. Sometimes it is referred to as Pascal, which is PA, Pascal. Yeah, sometimes it is referred to as Pascal. Now, if you recall, when we are talking about Hooke's law in study section 5, I said when you apply stress on a body, it will deform elastically or plastically. Now, in the case of liquid or fluid, that stress is referred to as pressure. And when pressure is applied on a fluid, what will happen is that the fluid will begin to flow. Assuming that you continue to increase the force that is on this container on your screen, you continue to increase the force on it, what will happen at the point in time is that there is possibility that this container fails, and once this container fails, the fluid in it will give way. So also, if it is in a pipe, if there is fluid in a pipe like this, once pressure is applied to it, the fluid will begin to flow, So whenever pressure is applied to fluid, it begins to flow. You know, in the case of material, when we are talking about Hooke's law, we said the body will deform, but in the case of fluid, it will begin to flow. There are some things that we need to take note when we are talking about pressure in a fluid. The force a fluid at rest exert on the walls of its container and vice versa they always act perpendicular to the wall of that container. Another thing that we are supposed to take note of is that an external pressure exerted on a fluid is transmitted uniformly throughout the volume of the fluid. When an external pressure is exerted on a fluid, the pressure is transmitted equally through in all directions of that fluid. Yes, you see, when you are pumping the water through a pipe and there is a pressure of the pump here, if you make a hole at the top of this pipe now, the pressure at which the water will be coming out in this place will also be equal here, because the pressure that is being applied to the fluid is equal at all direction. So it's being transmitted uniformly. Then the pressure on a small surface in a fluid is the same regardless of the orientation of the surface. You see, these things that are your attention is being called to. These are the principles by which some of the things that we use in our day-to-day life, these are the principles by which they operate. Like you are opening your tap in your house, you are using some electric, hydraulic material, your hydraulic pump, your braking system, and also these are the things that guide their operation. Now let us go on to consider the relationship between pressure and depth. Now, when we are talking about pressure and depth, there are some mathematical equation here that will make us understand it even more clearer. The pressure that is inside a volume of fluid depend on the depth below the surface. If a tank of height h, as it is seen on the screen, and with a cross-sectional A is filled with fluid of density rho. So now here, if this is the weight of the fluid that is inside this container, you know, as the fluid is filling the container, it is exerting a weight downward inside the container on whatever surface it is on, and there is a height h to consider, and this is the cross-sectional area of the material. If you recall, if you want to calculate the volume of a cylinder, the volume is area multiplied by the height of that material. So that is what will give us the volume. You know, unit of volume is meter cube, area is meter square, and height is in meter. So we'll get meter cube. Now that is volume. And if you recall, if you want to calculate density from our previous study session, we said density is mass over volume. So from this equation, if we make mass the subject of the formula we are going to have mass to be equal to density multiplied by volume. So that is why we are having this equation here. And you know that when we are calculating the weight of that water, said weight is mass times gravity. So if we now equate what we have determined mass to be here, if we equate it into the formula of weight. So we are going to get the formula for weight to be equal to density of the fluid multiplied by the volume, which is area of the container, and height, which the fluid occupied, multiplied by the gravity in relation to this equation and this equation of density and volume also. Now, if you recall from our previous slide, I said pressure is equal to force over area. Now, from this, just substitute all these equation into what we have here. Force is mass times acceleration due to gravity. And as mass times acceleration due to gravity here is the weight of the fluid that is inside the container. And we have determined the weight of the fluid to be density, volume, and gravity, which is volume is area multiplied by height. So now, if your area is common to both, so you are going to cross it out. So that is why we now have the pressure of this water on the container, the pressure that this fluid is exerting on the surface of this container is equal to density multiplied by height multiplied by gravity. Now, if you see this picture that is here, it's telling us the relationship of pressure and depth. Now, see this hole that is closer to the top, because the height is almost close to zero, that is, it is closer to the surface, the pressure here is very small. That is why the force at which, the pressure at which this fluid is coming out from the container is very low. And now see the pressure at the bottom of the container. You can see that it is very strong. So now, this is just telling us that this is the reason why it is difficult to swim at the bottom of the ocean. Why? Because the weight of the water will be much even at the bottom because of the height. So it will be difficult to swim when you are deep inside the water or ocean. So that is why it is important for us to understand the relationship between pressure and depth. And if you can see from the formula that is up here, you can see that this pressure is directly proportional to height. The higher the height, the higher the pressure at the bottom. Did you understand it? That is what it is just trying to tell us. We know that the density of the fluid is constant, the acceleration due to gravity is constant, but the height can vary. The higher the height, the higher the pressure. The lower the height, the lower the pressure. So that is what is happening here. All right. Now, the next thing for us to consider today is Pascal principle. Pascal principle, also known as Pascal law, is a fundamental concept in fluid mechanics. Pascal principle states that when a change in pressure is applied to an enclosed fluid, it is transmitted undiminished to all portions of the fluid and to the walls of its container. This means that if you apply pressure to a fluid in a closed system, the pressure will be transmitted equally throughout the entire fluid and to the wall of the container. Now, one practical application of Pascal principle is in hydraulic lift for automobiles. As you can see from the screen, when this force is applied here, you will recall that Pascal principle says the pressure is transmitted no matter the shape throughout the surface of that fluid. So this pressure transmitted here will just be transferred automatically to this place. And because of the area here, it has gained an advantage. So that is why it is so easy for us to lift our cars when we have flat tire. All we need to do is just to put the jack at the bottom of the car, and we'll begin to apply small force. And that force is what will be lifting the car up because it's applying Pascal principle. Also, have you ever imagined when you are driving and you are speeding, let's say at 100 km/h or so, and you just apply your brake and you discover that the car stopped suddenly? The principle by which that operates is through Pascal principle, because the pressure that you apply on the pedal of the brake is transmitted through a fluid to a bigger or a larger surface area that activated that the car be stopped. So that is what is happening. So from this place, what is happening here is that pressure at the small point is equal to the pressure at the bigger point. So P1 equals P2. So what this means is that the formula of pressure, which is F1 over A1, that is the force you apply here over this area here, will be equal to pressure at this place, which is P2, which is F2 over A2. So can you see? On the other hand, you can say pressure P1 equals constant, which means pressure is constant throughout the surface of the fluid, even to the other end. Now let's see this example. It said in a hydraulic press, a small piston has a cross-sectional area of 5 meters squared and a large piston has a cross-sectional area of 100 meters squared. A force of 500 Newton is applied to the small piston, and we are asked to calculate the force exerted on the larger piston. That is, when F1 is applied here to this fluid here, a pressure is created on the fluid considering this surface area, and the pressure is now transmitted throughout the fluid from this place to this place, even to all the fluid inside this bigger container now. And that pressure will now be used to lift whatever it is that is here. So we'll call this one here F2. So will be used to lift this F2. So if we are to calculate it, recall I said P pressure at this point equals pressure at this point. So the formula now is F1 over A1 equals F2 over A2. Can you see? That is the formula that we are going to apply. F1 over A1 equals F2 over A2. Now from this question, what are the things that are given? We are given A1, we are given A2, and we are given F1. So we are supposed to calculate for F2 to see what that thing is lifting up. So if you substitute all these given value into the equation, you are going to have something like this: F2 over 100 equals 500 divided by 5. And making F2 the subject of the formula, you have 500 multiplied by 100 divided by 5, which will give us 10 kilonewton. So that is what the weight that the force of 500 Newton will lift using this process. You can see how it applies now, that you use small force to pump your hydraulic jack and is lifting a heavy weight. So that is the principle that is at play. The next topic for us to consider is Archimedes' principle. Archimedes' principle is a fundamental law of physics that explains how objects float, or sink in fluids. Archimedes' principle states that the buoyant force on an object is equal to the weight of the fluid it displaces. Now let me explain this further. When you have a bowl that is full of fluid, let the fluid be water, and you take, let's say, a stone of this big and you throw it inside the water. What will happen is that the level of this water will increase. Now, the value by which this level of the water increase is the weight of the material that you drop inside that water. That is what Archimedes' principle is just saying. It's saying that the buoyancy, that how objects float or sink, is governed by Archimedes' principle. That the buoyant force of an object is equal to the weight of the fluid it displaced. Now, according to Archimedes' principle, when an object is immersed in a fluid, it experiences an upward buoyant force which is equal to the weight of the fluid it displaced. Now, this principle allows us to calculate the buoyancy of any floating object in a fluid. Now, it is this principle that ships use to operate on the sea. You will discover that there are some ships that they will say that the depth of a river is not so much, so they cannot come to that area, because possibly when the ship gets to that level of sea is going to cause problem, possibly sink or something. Is as a result of this Archimedes principle. Now, from this principle, it is important for us to note that an object will float in a fluid if the average density of the object is less than the density of the fluid, which means the object that is being that is inside the fluid, it will only float on one condition, and the condition is that the relative density or the average density of that object, assuming that the object is made up of different materials. So the density of all those materials, when you add them together and you determine the average of that density, that means the average density of that object, it must be less than the density of the fluid. What is simply saying is that that object must not be heavier than the fluid on which it is inside. The second one there says an object will sink in a fluid if the average density of the object is greater than that density of the fluid. So it's still rephrasing what the first one says. Assuming that the density of this stone is 50, that is 50 kilogram per meter square, per meter cube, that is the unit of density. And if density of water is 100, it means that this stone will float inside the water because the density of the stone is less than the density of water. But if the density of this stone is 100 and the density of water is 50, it means that this material is heavier than the water, so the stone will sink. And the third one there says an object will be in equilibrium at any submerged depth in a fluid if the average density of the object and the fluid are equal. Let's say the average density of this material now is 100 and the average density of the fluid is also 100. So the material will be at equilibrium, it will be floating. And the formula to calculate the buoyant force, which is the resisting force that is making the material to float inside the fluid, inside the liquid material, which is F buoyancy, is the weight of the water displaced, which is volume times acceleration due to gravity times density. as you can see on the screen here, which is the volume of the water, the density, volume of the fluid, density of the fluid, and the acceleration due to gravity of the fluid. So the next thing to discuss today is hydrodynamics. Now, hydrodynamics, from the beginning of the class, we said it relates to fluid in motion. When we have fluid in motion, what is happening inside the fluid? There are two things that might be happening. It might be flowing laminarly or is flowing turbulently. So when we talk about laminar flow, what laminar flow simply means is that, as you are seeing on your screen, this is a pipe and there is a fluid that is going through it. Said the motion of that fluid is not irrational. They are flowing in a streamlined way. This kind of movement is called streamline. You can see a parallel movement of the fluid. It's called a streamlined movement. Any fluid that is flowing in a streamlined movement pattern is referred to as a laminar flow. On the other hand, if there is a random movement in the flow of fluid, we say such movement is a turbulent flow. To explain this better, when there is a movement and there is a sudden change in direction, at that point that there is a sudden change in direction, there's bound to be a turbulent movement there, because there won't be a streamlined flow of the fluid. So that is what turbulent movement is about. So turbulence usually occur at high speed and when there are obstruction or sharp bend in the parts of the fluid. So that is when turbulent movement usually occur. So the next thing that we are going to consider is flow rate and equation of continuity. Flow rate is a measurement that tells us how much liquid is moving in a certain amount of time. It is like how fast water flows out of a pipe, or how much blood our heart is pumping. It is flow rate that determines it. Flow rate is important because it helps us understand how fluid moves and how much volume they can transport. Flow rate can be measured in different ways. One way is by using volumetric flow rate, which means the volume of the fluid that pass through a given area per unit of time. And another way is to use mass, which is referred to as mass flow rate, which measures the mass of a substance that passes per unit of time. So both of these measurements help us understand how much fluid is moving and how fast they are moving. The formula for calculating flow rate is shown on the screen, which is referred to as Q, which is flow rate, which is equal to the velocity at which the fluid is moving multiplied by the area, which is the cross-sectional area of the material through which the fluid is moving. And from this formula, we can see that flow rate is directly proportional to the area of the pipe and the velocity of the fluid. So if the area of the pipe increase or the velocity of the fluid increases, the flow rate will also increase. Now let us see the equation of continuity. What is the equation of continuity telling us? It's telling us that the flow rate at point 1 here must be equal to the flow rate at point 2 here, which means that if the velocity here is 2, for example, and the area is also 2, when we come to this place, since the area has reduced, let's say the area is 1, the velocity automatically will increase to 4. That is what this is trying to tell us. Now, if you see these two analogy that I just gave you, if you multiply the flow rate at this point, which is the velocity and the area, your answer will be 4. And if you multiply the velocity and the area at this point, the answer is still what? Is still 4. So that is what the continuity of flow is just trying to tell us, that the Flow rate at point 1 must be equal to flow rate at point 2. So that is why we are having this equation A1 multiplied by V1 equals A2 multiplied by V2. By default, density should be in consideration also, but because the density at both sides are equal, because it is the same fluid that is passing from one point to the other, that is why the density has cancelled out and is no more in the equation. So that is what equation of continuity of flow is telling us. Now let us consider Bernoulli equation. Bernoulli equation is a fundamental concept in fluid dynamics that help us understand the relationship between pressure, speed and height in a fluid. E state that when the speed of a fluid increases, the static pressure or the po ten tial energy of the fluid it will decrease. Bernoulli equation can be derived from the principle of conservation of energy, which states that the sum of all form of energy in a fluid remain constant at any point in time. So this means that at the speed of the fluid increase, the the kinetic energy increases while its po ten tial energy and internal energy decreases. Now see this formula on the screen. The P here is telling us the static pressure at the point of entry of the material, and the second equation here is telling us the kinetic energy, and the third one here is telling us of the po ten tial energy. You know that we said from the energy conservation principle, said the total energy in a system is constant. And when we are talking about the total energy in a system, especially for a fluid system, you talk about the energy exerted by the pressure, the kinetic energy, energy of the movement, and the po ten tial energy, energy po ten tial energy in the system. So when you add all this energy together, he said it has to be constant. What this constant means is that all this energy at point A is equal to this energy at point 2, at point B. So that is what he's saying. And the po ten tial energy that is being considered is the height by which the pipe is being raised, or the yes, the pipe is being raised. That is what is in consideration. So in an instance where the pipe or the container that is transporting the liquid has a flat surface, what it means is that our H1 and H2 will be the same, their level will be the same. So which means the po ten tial energy at that point will just be density and gravity, and by default they will cancel out. So that is how it is. So on this note, we have come to the end of our discussion. I will encourage you to look through your study material to understand better the concept that we have discussed in this video. So thank you for listening. See you in the next class.